In this problem, we are given a polar equation r squared equals to cosine 2 theta plus sine 2 theta. We need to convert it to its equivalent Cartesian equation. Let us begin. If we are provided with a Cartesian equation, then we can easily go to its polar form by making the replacement or making the substitution that x equals to r cosine theta and y equals to r sine theta. So this is the polar form of the x and the y coordinate. Here x is given in terms of r and theta. Now if we want to express r in terms of x and y and theta in terms of x and y, then what we can do, we can square x and add it to square of y. So this is going to give us r squared. So this is how we can represent r in terms of x and y, and then tangent of theta will be equals to y over x. So we're going to use this fact. Now, since we are given a polar form, there's a little bit of trigonometry that is involved. So let's start with a given equation. So here we have r squared equals to cosine 2 theta plus sine 2 theta. We don't have an issue with the expression on the left hand side. We have r squared. We can simply replace with x squared plus y squared. But we have to work around cosine 2 theta and sine 2 theta. So let's brush up our trigonometry here. So cosine 2 theta, what we have to do is convert it to tangent theta. Now cosine 2 theta, that's a standard identity with a value given by cosine squared theta minus sine squared theta. Now what we can do, we can rewrite this expression as cosine squared theta minus sine squared theta divided by 1. The reason why we've written 1 here in the denominator, because we get another identity which is cosine squared theta plus sine squared theta, that's 1. So let's replace the denominator with cosine squared theta plus sine squared theta. Now what we'll do, we'll divide both numerator and the denominator with cosine squared theta. So in the numerator, cosine squared theta over cosine squared theta, that becomes 1, minus sine squared theta over cosine squared theta, that becomes tangent squared theta, divided by, similarly in the denominator we have 1 plus tangent squared theta. The cosine of 2 theta in terms of tangent of theta can be expressed as the ratio 1 minus tangent squared theta to that of 1 plus tangent squared theta. So that will be 1 minus tangent squared theta divided by 1 plus tangent squared theta. Now coming to sine 2 theta, we'll also have to convert sine 2 theta to tangent theta. The sine 2 theta, let's work with sine 2 theta. This has a formula given by 2 times the product of cosine theta times sine theta. Like the previous one, we can also rewrite this as 2 times cosine theta times sine theta whole divided by 1, and we can replace the 1 in the denominator with sine squared theta plus cosine squared theta. Fine. Now what we'll do, we'll divide both the numerator and the denominator with cosine squared theta. So that means we have 2 times cosine theta sine theta divided by cosine squared theta. So one of the cosine theta gets factored out and we're left with sine theta over cosine theta, which is nothing but tangent theta. Coming to the denominator, we have sine squared theta over cosine squared theta. So that becomes tangent squared theta plus cosine squared theta over cosine squared theta, so that's 1. So that means in terms of tangent theta, sine 2 theta can be expressed as the ratio to tangent of theta over tangent squared theta plus 1. So we're going to replace this in place of sine 2 theta. So we have 2 times tangent theta divided by 1 plus tangent squared theta. Now what we'll do, we'll start by substituting the value of tangent theta with y over x and r squared with x squared over x squared plus y squared. So we get x squared plus y squared on the left hand side. On the right hand side we have 1 minus tangent squared theta, so that's y over x whole squared divided by 1 plus y over x whole squared added to 2 times tangent theta, so we have y over x whole divided by 1 plus y over x whole squared. Let's further simplify. So we're going to multiply both numerator and the denominator with x squared. So this is going to give us x squared minus y squared divided by x squared plus y squared. Similarly, we're going to multiply both numerator and the denominator with x squared for the second term. So we get 2 times xy divided by x squared plus y squared. So this is equals to x squared plus y squared on the left hand side. Further simplification is going to give us x squared plus y squared equals to So here, let's combine the two fractions. We have a common denominator, x squared plus y squared. And in the numerator, we have x squared minus y squared plus 2xy. Now, we can cross multiply. We get x squared plus y squared whole squared. And this will be equals to x squared minus y squared plus 2 times xy. So this is going to be the Cartesian equivalent of our original polar equation, which was r squared equals to cosine 2 theta plus sine 2 theta.